Okay, today we're going to learn about geometric mean and similar right triangles. If you read your table of contents, it says that you are supposed to take notes on page 52 in your ISN. So if you currently do not have your ISN out, get that out right now so that you can take notes on page 52. And at the top of page 52, I want you to write geometric mean. Now, to be honest, the geometric mean has nothing to do with the algebraic mean where you add up all the numbers and then divide by how many there are. It has nothing to do with that. But I will show you why it's called the geometric mean in just a moment. Okay, on your picture, or on your paper, I want you to draw this picture. I'm going to draw a right triangle that looks like this. Okay. And then from this side here, I want you to draw a segment that is perpendicular. So you've got your right triangle, and then you just drew a perpendicular segment there. What you actually have in this picture is 3 right triangles. You have the big right triangle that we just drew. You have this small right triangle here, because see, if that's 90, then this angle is also 90. So you've got this small right triangle here, and you have this medium right triangle. So put a star over here and write, there are 3 similar right triangles in this picture. There are 3 similar right triangles in this picture. Now, if you want to know, I can show you why these 3 triangles are similar, and I can show you how to match up the corresponding sides. That gets a little detailed, and I feel like it would lose several of you. So we're going to jump straight into how to solve the problems. But if you are interested in knowing why it works, or it just doesn't make sense to you and you want to understand where these proportions are coming from, I'll be happy to show you. So to solve these problems, what's going to happen is you're going to see a picture like this, and you're going to be given some information about this picture. For this segment right here, I want you to call this A. I want you to call this segment B. And on this perpendicular segment right here, I want you to put an X. So A and B represent numbers, and then X is what we're going to solve for. To do this, I'm going to teach you 2 dances. So here's dance 1, and they're not real full-out dances. We're just kind of learn some hand motions, okay? This is going to be weird doing this with a video, but hopefully it'll work. Okay, so for dance 1, I want you to stick your hand out in front of you. Here's dance 1. If your hand's not out in front of you, you're not going to learn this. So go ahead and put it out in front of you. You're going to go over, up, down, over. Okay, do that again. Ready? So go over, up, down, over. So when we apply that to this picture, over is A, up is X, down is X, and over is B. So over, up, down, over. That is the proportion that we're going to write. In setting up this proportion, we are actually setting up corresponding sides of these 3 similar right triangles. Put this back on the stand so it quits jiggling. Okay, so for dance 1, over, up, down, over. We're going to do A over X equals X over B. Over, up, down, over. Okay? Do you see how the X's are diagonal from each other? Well, when I cross multiply here, I'm going to get X times X, which is X squared. That's why it's called geometric mean. When you set up your proportion, you will always have something diagonal from each other where they are identical. So sometimes this will be X, sometimes this will be a number. Like you could have a 14 here and a 14 on top. But geometric mean is when you have this diagonal is the same number or the same variable. Okay? So before we talk about dance 2, there's 2 dances for this. Let's go ahead and do an example of what dance 1 would look like. So here's our example. Draw another right triangle and draw the perpendicular segment. Call this part 2, this part 8, and this part X. So if I give you this picture and I want you to find X, you are going to use the fact that there are 3 similar right triangles in this picture to set up a proportion. And to help you set up your proportion, you're going to use dance 1. Do you see how this middle segment has something on it? Now sometimes this will be X and sometimes it will be a number, and your X will be one of these 2 numbers. But when you have something on the middle, that's dance 1. Okay, I'll show you the hint for dance 2 later, but when there's something on this middle segment, that's when you know you're using dance 1. So put your hand out in front. Since we are using dance 1, we are going to go over 2, up X, down X, over 8. So over, up, down, over. So to set up our proportion, we're going to have 2 over X equals X over 8. And we're going to cross multiply. 2 times 8 is 16. X times X is X squared. Now from here, do not put 2X here. X times X is X squared. We're not going to divide by 2 to solve this. To solve this, we're going to use the square root. If you don't know how to do the square root on your calculator, come find me and I'll show you. The square root of 16 is 4. The square root of X squared is just X. So our answer is 4. Now, I can't be a math teacher without talking about this part. When you take the square root of 16, there are actually 2 answers. 4 and negative 4, because negative 4 squared is also 16. But in geometry, our X represents the length of a segment. We can't have negative 4 be the length of a segment. So even though technically the square root of 16 is positive 4 and negative 4, we only use positive 4 because we're talking about a length of a segment. So that's the answer to this problem. Okay? Now dance 2. Here's the other way you'll have to use this. Okay, go back up to your original picture that you have in your notes. And on this side right here, I want you to put a Y. And so we're ignoring the X right now. So the X is gone. Do you see how this picture, I've got some things along the bottom, and then I have the Y over here on the side, but I have nothing inside the picture. If your triangle is empty, so that X is not there right now. If your triangle is empty, that's your clue that you're using dance 2. So put a star right here and write empty triangle. If there's nothing inside the triangle, you're using dance 2. So dance 2, ready? Have your hand out again. You're going to go, start over here, all the way, up, down, part way. So do that again. Start over here, all the way, up, down, part way. Now notice I'm saying part way and not halfway. So when we look at our picture, all the way is A and B together. What is A and B together? A plus B. It's not going to be AB because that would be A times B. So all the way would be A plus B. So for our proportion, A plus B, all the way, up is Y, equals, down is Y, over partway, B. So all the way, up, down, partway. So A plus B over Y equals Y over B. Now this dance is reversible. This dance is reversible. Your Y could be over here on this side. If your Y was on this side, you would start at this corner and go all the way up, down, and your part way would be the A. So whichever side your variable is on, that's the side you go towards when you do your all the way. So let's do an example of what dance 2 will look like. Got your right triangle. Now draw your perpendicular segment. Put a Y right here. 2 and 8. Okay. Do you see how the triangle is empty? Empty triangle means dance 2. When the triangle has something in it, it's dance 1. Okay? So to set up your proportion, remember you're going to go towards this side. So you start over here with your hand. All the way, up, down, part way. So your all the way is 8 plus 2. 8 plus 2 is 10. All the way up is Y. Down is Y. And then part way is 2. All the way up, down, part way. Okay? Now we cross multiply. 10 times 2 is 20. Y times Y is Y squared. Do your square root. Again, if you don't know how to do this on the calculator, let me know. And when we type in the square root of 20 on a calculator, we get 4.47. And that's our answer for Y. Okay? Now, you are going, if you look on your ISN, you have some problems assigned to you that you're going to do. So 3, 5, 9, 10, 15, 16. So you're going to find this worksheet in your packet and you're going to do those problems. I want to take a second and talk about which dance you're going to do in each one. So on number 3, right here, do you see how there's an X right here? What dance is it when there's an X on the inside? Dance 1. Even if that was a number, it would still be dance 1. When you look at number 5, see how number 5 is empty? If it's an empty triangle, then that means you're doing dance 2. Okay? Look on the back. I want to show you something on number 15. Okay? On 15, do you see this X? This X is the entire thing, right? So look at the 48. What dance am I using for this problem? Dance 1, because I have something on the inside. Dance 1 is over, up, down, over. Well, if I'm going to do this first over part, I need to know what that piece is. If the entire thing is X, this part is 64, what can I write to represent this unknown piece? The whole thing is X. Take away the part you don't want, and that leaves you with the part you do want. So this piece is X minus 64. Okay? So when you're doing 15, this piece is X minus 64. On number 9, again, this whole thing is X, but which dance are we doing on number 9? There's nothing inside, so this is dance 2. So you're going to do your all the way, up, down, part way. When you do your all the way on number 9, all the way is already X, so you're not going to need to do anything extra to this problem because your all the way is already X. Okay? Let me know if you have questions. Make sure you check your answers when you're done.